Hi, thanks for making it all the way up here. I got here and there was like one person. And I was like, oh well, that's okay. But there's a few more of you, which is really, really nice. So thank you for staying awake this long on, I know it's a long day, and just sharing the time with me. So I'm going to talk a little bit about serverless computing with one of my, I'm not sure if I should say this, favorite Apache projects. Like, am I allowed to have favorites at the Apache Roadshow? Anyway, I love OpenWhisk. I'm a contributor, although mostly to docs rather than code. I like open the issues rather than closing them. Like that's kind of my role in the project. So yeah, I'm a developer advocate at IBM, so I'm coming at this really strongly from the developer side. You can ask me ops questions, but I work for a cloud hosting provider, and they don't let me do the ops there. So I probably can't answer them, although I can pass you on to the excellent humans that can. So let's start off with, like, what even is this serverless thing? So the idea is that you write a snippet of code, a whole unit of code, maybe a function. Does anyone here know how to write a function in any language? Yeah? Then you can work with serverless. That's how high the entry barrier is. So you write your function, you deploy it to the cloud, and you set up some rules that says when this happens, you should run my function in response to that. So the thing that happens might be a database change, an item on a message queue, it might be an incoming web request, whatever it is, when that thing happens, do this thing that I just wrote the code for. I didn't deploy a virtual server, I didn't set up an operating system, I didn't do bind or other sysadmin type setup things, I just went code, there you go. So that's quite cool. The barrier of entry is really low, and that's awesome. There's a lot of cool things about serverless. If the event happens and we're already, like the function's already busy doing something, we'll just run another one. So this platform, you write the function once, it is going to scale on demand horizontally as much as you need it to. And you can constrain this so your credit card doesn't melt. There are some, there are some rules. So that's quite exciting. I think the scaling aspect is really interesting. If you have either very low traffic, trickly traffic, or like bursty traffic, you don't know how, it's difficult to do the capacity planning. This is very interesting. The cost model is really, really interesting. So it's pay as you go. If your function never runs, it never costs anything. While it's running, it is costing you money, but if you look at the pricing on any of the serverless platforms, the hosted ones, then you'll see it's like $0.0000, right? And they all have generous free tiers. So you can run really low traffic stuff and prototype apps quite easily, all within free tiers, along the hosted versions of this. So why is it called serverless? I don't know. I think geeks should let me name things because it's a really, really bad name. I would like to know that the servers they exist, because otherwise how would this work? They are alive and well. What really happens is your function gets containerized and we run it, we get the container and put it on the container host and then run it at the moment that the event happens when you need it. And we leave it there for a while. So if your events are happening a lot, we just reuse the same one. And this is a good explanation of why serverless has suddenly become such a hot topic now. And the truth is, this couldn't have happened before. Everything that's happened in the container landscape, which, you know, like firmly over in the world of even more awesome ops than before, everything that's happened there with Kubernetes and the scheduling and all of that enables serverless. We are building tools for developers on the shoulders of fabulous stuff that's happening in a completely different part of the industry. So serverless has come along now because we're ready now. We can tool it now. Some of the early serverless implementations, including the very early OpenWhisk efforts before it was an Apache project, had some very interesting container stuff going on because Kubernetes wasn't there or wasn't ready. So is it just an of-the-moment hipster thing that we're hearing a lot of hype about? Will it be gone next year, a bit like a JavaScript framework, replaced by another new buzzword? I don't think so. I'm going to stick my neck out and say serverless is not just for hipsters. Think it's a real tool. Does it solve real problems? Yes, with a small caveat that maybe it doesn't solve all of them. But there are definitely some problems that are a great shape for serverless, where I think this kind of platform is a really good fit, and that's both in terms of the shape of the problem, but also the shape of the person who can use this tool. I think this is opening the door to a bunch of people who are not traditionally full stack or back-end devs, because all you've got to be able to do is write function. So there's a lot of new people starting to take advantage of this. I think it's a slow burn because there's a lot of education. It's quite a new idea. But I think we will see this continue to be disruptive over the years to come. So some things that I think it fits really well for, microservices, that you can tell this, I think this is a good fit, because tomorrow I'm giving a talk about serverless microservices. Pop back here after lunch tomorrow, and you can have more of this. I do think it's a great fit, because with the microservice, where you kind of start from a user story and then define the endpoints that you need, and then you're mapping each of those endpoints with a verb combination onto a function. And those functions are all independent. They can be changed and switched independently without hurting anything that's already live. And you can even have different people working on different areas really, really easily. I think it's a really nice kind of modular approach. And we use serverless in conjunction with an API gateway. And I'm kind of aware that a lot of the serverless stuff that you might have seen is on the hosted providers. IBM Cloud has a hosted functions as a service offering. It's based on Apache Openwhisk. There are lots of competitors in this space, including very nearly other providers that also offer hosted Apache Openwhisk. We know lots of people running their own OpenWhisks. It's also available on hosted services. All of the serverless platforms, including Amazon Lambda or whatever, with which this is comparable, will have some sort of API gateway that will give you the routing, nice paths that you want, pointing to your functions. And we'll also give you some extra stuff at that level, like security, rate limiting, that kind of thing. I have examples of API gateway in tomorrow's talk, where I'm going to try not to give my whole microservices talk now, and instead keep talking about some of the other use cases that I think are a lovely fit. The one I use a lot, maybe because I'm a developer advocate, so I tend to write sample code rather than production code, is one-off endpoints, stuff that you really don't want to set up and become responsible for a server to do these things. If you are writing an Alexa skill, I think the Echo Dot is out in Germany as well, so you might be familiar with it. It's a small device. You speak. I always say she listens, she doesn't listen. That's obviously not how that works. Amazon sends the recording of your voice and parses it and decides what to do, and then sends a webhook. So you define when this thing happens, hit this endpoint. Serverless is an obvious fit for that. And I just got scared by demoing with the Echo Dot, so I've stopped traveling with her now, because I ran that demo 5 times successfully, and I think I've run out of karma. So you could just imagine a demo with an Echo Dot. But that's the kind of thing where if you publish that, it could be quite popular, or nobody might use it. And you don't need to care, because you can just either put it on your existing Apache Openwhisk or use one of the hosted platforms for it. If you have a static site with just a little bit of dynamic functionality, contact form, mailing list sign up, anything like that, it's just going to save to a database or send an email. You can host a static site on S3 or whatever. You don't GitHub pages. You don't need to run a web server for this. So you can use a serverless function just to catch that incoming web request and do whatever the thing is that you need to do. So you can write it to the database, send the email, do whatever you do. The OpenWhisk community has a serverless endpoint on its Slack sign-up form, of course. And it's quite a nice use case. I use it quite a lot for handling incoming webhooks. Serverless is all about event-driven. Something happens, we respond to it. So I use it quite a lot for when this thing happens on GitHub, run this function, and maybe if I find the following things, do something else about it. My team set up one which was, if the commit changes a CSS file and Lorna was the committer, sound the alarms. Because I am not a front-end dev, and that makes them anxious. So they made the Slack bot talk when those things happened. So if you're responding to something like Zapier or Ifty, this is a great way of doing that. Twilio, Nextmo, any of the telecoms APIs, you're receiving an SMS. It's a really, really nice fit that you wouldn't necessarily want to. It's not just about setting up the server, it's then the overhead of having to maintain that. Or you end up deploying a bunch of things to one server, and then, yeah, I have one of those. It runs my website, my friend's website, and some other tools that I like, and it's nonsense. Where I think serverless is really interesting is how much it's going to enable geeks of other disciplines. So people who are technical, but they're not, it opens up server-side coding to people who are not server-side coders. So if you are doing mobile or front-end stuff, often there are pieces which cannot go on the client. They need to go on your own server. So I'm thinking of API keys, back-end auth, that kind of thing. Small pieces, 3 endpoints. By using serverless, we can give that tooling directly to those people. They can code, but they might not want to know how to administer a Linux box and take care of it in an ongoing way. So it opens a lot of doors to people who have a lot of skills that are not directly these skills. I'm also seeing it used more and more in the data world. A really common use case to respond to is, there are things on this queue, do stuff. And so transforming data or reacting to data is a really nice use case. If you think about how we deal with particularly potentially large amounts of data, things like MapReduce is essentially a distributed system. And all of the serverless platforms give us that independent atomic pieces of work scaled horizontally. So when you're working with data sets as data scientists doing some transformation or some manipulation, whether it's I need to batch convert this stuff so that I can run some analysis, or whether it's this sensor data is coming in and it's not in the format that I'm expecting, we bought sensors from different suppliers, and the Internet of Things has no standards. So we're going to manipulate them all into a common form as they come in. Serverless is great at doing that one simple thing over and over on demand. And I see that used more and more. A special shout out to another of my favorite Apache projects. It's CouchDB. When you write to CouchDB, you can get an event. It has a changes feed. So when something happens, insert or update, then you can get that in a feed, and OpenWhisk knows how to respond to it. So I work quite a lot with CouchDB, and this is a really nice, I wrote to the database. Okay, so we assigned this thing to somebody, let's notify them in Slack. And this gives me a really nice integration point. So let's talk a bit more about Apache Openwhisk itself. It's a relatively new project, certainly in Apache terms, because a lot of the projects in the foundation are really, really well established. In fact, OpenWhisk is still in the incubator, although we're working towards graduation and learning to be more of a grown-up Apache project and a bit less. We started off as kind of having a lot of contributors from one company. We now have contributors from a bunch of companies. So I'm from IBM. We were the original conspirators, if you like. We have Red Hat and Adobe also as big contributors now, looking to run their own hosted versions, which I think will be great to have other providers of this. We see a lot of clients prototyping, not knowing if they'll deploy to our hosted cloud or run it in their own data centers. And you can choose one and then choose the other. It's open source, that's the point. We have contributors from a variety of backgrounds, so we do have a bunch of individual contributors and community contributors who are just using it and wanting to make it more the tool that they need, and I think that's really, really important. It's something that's been striking to me working on this project. This is a couple of years, I took this screenshot last week, so a couple of years worth of commits, and it's been pretty steady, and it's, you know, it's coming along. Out of the box, we support a bunch of different languages. So we've got Java and Node.js, which I think are pretty standard on the serverless platforms. You see a lot of Python as well. We also have PHP, which was a community contribution from an individual, which I think is great. And also Swift, because we're crazy about Swift at IBM, which is nice. If there's anything here that doesn't meet your needs, you have a couple of options. One is to just wrap it up in a Docker container and deploy that, and it'll just get run as it is. So you're sort of doing your own packaging step. There are also situations where that makes the most sense because you have large dependencies or something like that, to do the packaging step up front so that your Docker container is just stored like that and then loaded from the registry. There's no init step. Not very many of those, but you can do it. Your other option is to contribute the runtime. So to build the structure to allow us to plug in your preferred language to this. I'm expecting to see Golang and maybe Kotlin appear on this list over the next few months, but I don't want to make promises. Go and look on the mailing list if you're interested. So that's all cool. I'm a developer, so we are going to dive into some code and do the hello world example, so you can all go home and try this and impress your friends. We'll start by talking about some of the terminology. I'm really conscious that I often use jargon because I live in this world. As with so many things, it's really important when you want a technology to sound exciting that you should use new words to refer to familiar concepts. So I've been around in PHP, which is my original language, long enough for when object-oriented programming was new and everyone was confused by methods, yet they were experts at functions, right? OpenWhisk, all the serverless platforms are a little bit like that. So instead of calling a function, we call it an action. It's going to run in response to an event. A trigger is the event. So the trigger is a database change, a web request, an item on a queue, or a bunch of items on a queue. We use the rule to map those two things together. So the thing that happens and the action, now I've said it's called an action, the rule is what joins the two things together. When this happens, do this. Database change on this database, right, run this action. Or maybe run a bunch of rules that does a bunch of things in response to that. OpenWhisk specifically has this concept of packages. Packages are a bit more than a namespace. They allow us to group our actions together, but we can also set, for example, parameters on the package if we need to give an API key or some creds that are available to more than one action. You can set it in just one place on the package if you want to. So I quite like that. Keeps things tidy, because once you get past hello world, your list of actions gets big really quickly. So the packages are a nice kind of namespace, but it's more than that, a way of grouping actions together. Because all these actions are small. Often we'll work with sequences, where each action has output that becomes the input of the next action. So the sequences are the pipe operators, and every action expects the input of the previous action. This is useful often because we can write little reusable pieces where we're copying and pasting code. We can just make actions and kind of put a sequence in the middle and then come back and write the next piece. So that's how we kind of build those very small actions up together and fit that around. You'll hear a lot about cold start when you start working with serverless. The cold start time is your action hasn't been used recently, or you've deployed a new version, or for some reason we haven't got the right version of the action ready to go. So we take the packaged container and put it on the container host. So you'll see typically, it's hard to put exactly a number on it, but a few hundred milliseconds. The cold start is measurable. You can tell If your action was cold started, like run it once, run it again, it'll always be quicker the second time. But it's not huge. If you have any sort of network call, API call, database access, then your cold start time is irrelevant for the execution time of your whole action anyway. It's mentioned because I think people worry about this a lot. In my experience, it's almost never a problem, but you should definitely know it's here. There are definitely some real-time applications where this would be a problem. So it's just there for you to kind of know what it is and know when you would be concerned about that. Okay. Hello world. I picked JavaScript because I wasn't sure what to expect from you all, and I think everybody can read JavaScript. My colleagues get cross if I call it the lowest common denominator of developers. They're all JavaScript devs. But hopefully you can all read this and get something from it. We've got a function. The function takes some parameters, and then it returns an object. Good. You can all do this. In your language of choice. In JavaScript, you're always going to return an object or a promise. Because if you have any kind of async operations, you need to return a promise so that the container knows it's not finished, and once all those promises are resolved or rejected, then we're done and we know that we can stop. The event loop doesn't work the same way as it does in a long-running node process. Or if you are newfangled in your JavaScript, then the async await stuff also works. But try and remember this, return an object or return a promise. I'm returning an object with a key of body here, because this is going to be a web action in about 3 slides' time. So you can return what you like, but I'm returning body because I'm going to use that feature in a moment. This args parameter contains a bunch of things. So you'll get some parameters that you set, and you can set these when you deploy your action to the cloud, or they might be set when you call your action. So you can call it manually, invoke it from the command line. More often, it'll be called because an event happened. So then you'll have parameters that are about the event. So you'll have the item that was on the queue, or parameters that relate to the incoming web request, or whatever makes sense here. So you can set them at deploy time, you can set them at runtime. They end up in the same namespace, which is really interesting. So you can annotate the parameters as being final if you set them at deploy time, which means they can't be overwritten at runtime. Sometimes you want them overwritten, like you're just setting some defaults in case they're not set. So it's as appropriate. There's a project underway at the moment to standardize the data that comes in from all the different events between the various serverless platforms. So the Cloud Native Computing Foundation are working on that at the moment. I think this will be great because serverless platforms are really not interchangeable at the moment. If you deploy to Lambda and then decide you don't want that lock-in, it's hard to get away at the moment. What else do I want to say about parameters? You can also set parameters specifically on IBM Cloud. So this is not an open source thing. On IBM Cloud, obviously, we offer databases and other types of APIs, like Watson APIs and weather APIs. You can bind. There's a bind command that lets you kind of say, yeah, I want to access that Postgres. So tell this package, I want access to that Postgres, and it'll use your login to put your credentials in the right place. So there's an extra way of adding that that's just on the proprietary cloud. All right. So we wrote some code, which is great. Now we need to deploy it. We deploy using this whisk. That's the OpenWhisk command line tool, WSK, whisk. First of all, I'm going to create a package. You'll notice that the command does not say create. It says update. And that's because OpenWhisk is an optimist. It is on your side. And if you run update and it doesn't exist, it will create it. And it means you can always rerun your script safely. So I use update everywhere. So I'm creating a package called demo, and I am zipping my index.js file, which you just saw with the hello world, into a zip file. You don't need to zip your code, right? 4 lines in index.js, you definitely don't need to zip that. But if you get past hello world, any kind of dependencies, you need to zip. So I hope that you will try this, try the hello world example, and then try something that needs zipping. So you get out of being able to do it in one file really fast. So we'll zip it. And then we create the action. So again, I'm using update because I'm instantly going to want to edit the JavaScript file and zip it again and deploy it again. So we'll use update. --kind specifies the runtime. So you can say what version of Node you want. I want Swift 3, I want Swift 4, it's Python 3, it's PHP 7, whatever. You specify that here. Then you give the action a name. That's this demo hello one. The demo is the package name. So it's package name / action name. And then the zip file. To run it, just invoke it, because we couldn't call it run, because we need big words to make it seem mysterious and advanced, right? So we call it invoke. You need this -- result. Without it, the action will be invoked. You will not see the output, right? It will be run, but it's fire and forget. So if you actually want to see what comes back, then you need -- result. Or -- blocking will give you a lot more information, so you'll see the parameters and any init time or anything. So that can be quite useful if you need to do any debugging, to use -- blocking instead. So we wrote some very simple JavaScript. We deployed the JavaScript to the cloud. We ran it. That's quite cool. I want to talk next about web enabling the actions, because it's trivial and kind of more useful than this. So we're still going to deploy the code, like we're still going to update the package, we're still going to zip the index file. The only thing that's different here is this --web true. That's saying I want this action to be web enabled. So then I can get the URL, I can just ask this action how I should refer to it. I'm running this locally, which is the joy of an open source project, local for development. Ask it what its URL is, and then curl that. If you are using the local installation, the SSL certificates aren't set up by default, so you probably need whisk with a -i and curl with a -k to just ignore the fact that none of these certs are verified. And you can just curl it, and you'll see, because I set that body as the key, as the object property, then you'll get the value back. You can also set headers and status code here, because it's going to be a web response. OK. A little bit more about packages. I feel like I said most of this. But one thing I wanted to touch on here is how the actions from different packages can interplay together. So you can, have an individual, a whole application made of code that you wrote in its own package, and then a whole other one, maybe a different microservice, in a whole other package, and that's cool. But sometimes we share things between packages, or different sequences pull in from different packages. And that might be stuff that we've written, that we have like a common set that we use, or it might be stuff that's already built in. So Apache Openwhisk comes with a bunch of built-in things. So we have, you'll see some other things that are a bit, like Cloudant. This is CouchDB, but Cloudant's the IBM marketing name. I assume this will get fixed at some point. So it doesn't need to be called that. And you'll also see some Watson stuff and some weather stuff. It is showing its IBM roots. I use the Cloudant one quite a bit. It's super helpful. The GitHub, Slack, WebSocket packages have actions that just format the data correctly to interact with those endpoints, either sending or receiving. So that's quite useful. The samples just has stuff to try. It has examples to look at and things that you can wire in. And you can call these really easily. They're all in a package called whisk.system. So for example, in the samples package, there's a word count action. And I can just call it with whisk. You can tell this is local, whisk-i. Whisk action invoke with -- result, because I do care what comes back. And then I can call it with its qualified name. So it's the whisk.system in the samples package, the word count action. And if I pass this payload with this string, it counts the number of words in the string. right? And there are 8. It's high-powered. I'm not sure why you would need this, but if you did, it's here. It's quite handy. And it's really easy to make use of those that are already built in. You can have an explore, and you'll find that you probably start to build your own reusable pieces of actions that come into sequences. Where's my diagram gone? Oh, that's a fail. Imagine a diagram where a user registers on a site, so the database change fires, which runs the cloud and please tell me what record that was you just created in a sequence with, so like get the record, next in the sequence, do my code, which is the thing I actually care about, and then finally, whatever message I just made here, send this to Slack, which will do the webhook with the Slack creds. I'm not sure what happened to my formatting there. And I think these sequences, these wiring together of your bits, common code that you share maybe with other parts of your project, things that were already built in. I think this is really an interesting way of building. Over the years in software development, we've been moving to more of a componentized architecture, and serverless it's just very rewarding to develop with because it's so quick. You don't need a lot of setup, you don't need to think hard about it, it's quite well established. So I would put this up, write some functions. I have like a favorite project structure that I use, and then just teach Travis to deploy it, and we're all good. Just keep pushing to Git, and it just deploys. So in terms of, we've used it a lot for a lot of our internal tools, just because we have access to the platform, and it's super quick and easy, and I can develop locally, which is great, and probably the biggest selling point of having it as an open source project. A lot of the time, if you work with Amazon Lambda or something, you end up needing development and extra cloud, like development accounts as well as production accounts. And with this, you can just have it locally, which I think is great. I've really, really enjoyed working with it. So I feel like serverless it's big news. There's talks at all the conferences, right? But it really means something to us as developers. It's something that should be a tool in our box. It should be, and it is something that we will continue to use occasionally or sometimes for a long time to come. I think our understanding of what the right problems are for serverless is still growing in a lot of ways. I think there are some really good use cases out there already, and there are some cases where people have been like, this is amazing, and moved everything to serverless, and then promptly moved it all back. Which, yeah, I can kind of see that. The actions are very small, and they're all independent, so you can get to 200 of them really quickly. And then you've got something that can be quite hard to manage. The tooling is still playing catch-up in some ways. So I think that's quite interesting. Having OpenWhisk in the Apache Foundation, I think really reflects being in touch with developers, being in touch with new stuff, wanting to make sure that we build in a way that we can all benefit from. Like I say, that we don't have a lot of public hosted versions of this yet, but we do see people running it. We need 2 communities, one for people who have to run this thing, and those people like me who are just like, hey, I can write code in any language and make it access it with just setting up web endpoints. I want that, right? So it's a young project, but I think it's something that's really important in the industry and within the foundation. I don't know how many of you are already using serverless or considering it. I'd be really interested to kind of hear what your use cases are, what your hopes and dreams are, what your concerns are, and kind of hear how that engagement is going, and how you feel it's going to fit in into your current workflow, and what you're worried about if you haven't started yet. I think that'd be really interesting. Cool. So I have some resources for you. There's the link to the Apache project. A link to the hosted IBM version if you just want to play with it quickly. So it's on the free tier. A link to my blog where I write more about this stuff. And a reminder that you can have more of this and a more like concrete example in tomorrow's talk. So I didn't want to overload you in the afternoon today, but I do have like a whole another talk tomorrow where I will do much less intro and a bit more hands-on stuff. So that's with me. We have about 10 minutes for questions if anyone wants to chat more, and if you don't want to chat more, that is also fine. Yes?
You have shown us very basic operations of the command line. How can I integrate it in my build environment? Is there some testing? Are there more tools or frameworks for OpenWhisk to integrate in my development environment?
I'm not seeing a lot of like ready-made plugins. There's a bunch of tools in this space, which I think might be interesting to you. The first one is Serverless framework, which is aimed to give you just a little bit more of a high-level approach than maybe what I've shown you here. I don't think it necessarily integrates with your IDE, but I'm a Vim user, so I wouldn't know. And that also aims to give you platform independence between all the different serverless platforms. And that might also be interesting to organizations who don't want to commit strongly one way or another. For the sort of development lifecycle side of questions, I tend to just have these commands run by Travis, so it deploys that way. I have seen a few testing tools that kind of set up some scaffolding and pretend to be OpenWhisk and pass in like known sample inputs and outputs. I don't want to be negative about those testing tools at all, but I think they are maturing. I think is the nicest way to say that. Like everybody has their own scaffolding setup. We're not really on common ground with that yet. I expect that to change, but currently there isn't really a standardized way of doing it. The logging and monitoring is pretty standardized, so everyone just pushing out to some sort of elk type stack. So that's, yeah, I feel like that end is under control, which it wasn't. That's changed quite a lot in the last 6 to 12 months. Am I answering your question?
Yes, a little bit, but the hard problem will be the debugging. How do you debug a function without server?
How do you debug a function without a server? It's not too bad. I mean, we're seeing some OpenWhisk local type projects. So the idea is that it just pretends to be OpenWhisk and you're actually running the JavaScript locally. Obviously, I'm running OpenWhisk locally when I develop, so I can hook in and debug that a bit. Say it again? Oh, yeah. I mean, there are servers all the way through. Serverless is completely the wrong name ever. There clearly are. It's like no ops, which is really just the best ops you've ever seen, right? I don't have to do the ops, but it's not like there isn't any. Yeah, I think the debugging is interesting. For the most part, you shouldn't get too bogged down in this because it should be many small components. Like if you have a real cyclomatic complexity and you're lost in your function, that's sort of a separate problem that the tools can't help you with. But yeah, the thing about the local scaffolding is it still very much favors just JavaScript, and that's annoying to me. Like, do you support these other languages or not? And I feel like these other tools don't yet support all of the languages. And it's not a standard solution until we have support for everything we claim we do. Like, oh, you can run Python, but you can't have any of this other stuff. It's not a full platform. So depending on your chosen tech stack, there's probably some different experiences there. Yeah.
So you talk about support for different languages like PHP and Python and so on. So can you give an impression what it takes in amount of time or effort to add support for a new language, and what it does mean to add support for a new language?
Okay, I'm going to give you...
I'm speaking especially about compiled languages,
okay.
Like C or Fortran.
I'm going to give you my best hand-wavy answer because I haven't built this. So with the compiled languages, with Java, with Swift, I think the process is pretty similar. So you create a Docker container that responds to two particular commands. One is init, takes the code, gets the dependencies, does the compile step, gets the container ready to run. And this is why the cold start is more painful on Java than it is on the interpreted languages. And then you have the run step, which is like, the event happened, go. And on cold start, we run the init first and then the run. So you need to create the container that has everything this runtime needs to like get its dependencies and run. And then you need to write the piece that does the init, and a little bit, it's not much, it's a little bit of wrapper. How much work is it? If it's your chosen tech stack, I think you can do this in a weekend. I didn't really mean it as a challenge, but that would be lovely. Yeah?
I have a little bit experience with AWS Lambda, and there you can specify what kind of resources you want and what events and so. Is it also possible with OpenWhisk not just to say this function, give it a little bit more, like how many CPU or memory or whatever, or start time, also to have it warm start?
We don't have the warm start thing. I think if you need warm start, you probably didn't need serverless. Maybe I'm being narrow-minded about that. But like, if you need a server that's always running, then get a server that's always running. We've already invented those. Yeah. You can just, yes, you can do keep alive to keep it warm. But I think that it's a bit unreliable because you can be garbage collected at any time. If you redeploy, then it's going to be cold anyway. Although a lot of people have a ping on the end of their deploy scripts for this reason. In terms of, sorry, what was the other part of the question?
The resources that I can definition of what is resources.
How big an action would you like? Yeah, how big is your function? So that's configurable on the server side. So you're going to configure that at namespace level with OpenWhisk. It's not very configurable, but we've recently boosted our resources as standard on the public cloud on IBM Cloud. If you're running your own, then you can configure that any way you want, but it's configured across the platform. So, awesome. Yeah, one right in the corner that you can't see behind the pillar. Hi.
Thank you. My question is, how would OpenWhisk integrate into an already existing infrastructure with, say, Jenkins and Travis and Kubernetes on the back end? Is it a completely new approach, or does it integrate into that?
How does it integrate to what you already have? So in terms of like Jenkins and Travis, the testing, like I say, is immature, so it's hard to automate that side of things. In terms of deploying the actions, I use Travis for that. I just set the environment variables that I need to pass in for config and run more or less the scripts that you see here. Obviously a bit more complicated on a slightly less trivial project. But I do have it, and that works really well. In terms of Kubernetes, I mean, it's Kubernetes backed. So if you already have Kubernetes expertise in your organization, then OpenWhisk is great because you already know how to do a lot of it. I'm not sure you'd necessarily want to integrate it to what you already have. I think it would always be like a separate thing that you installed. Does that make sense? Yeah. I'm not very good at the ops questions.
It would be a completely different approach to do the very same thing, to deploy services onto servers, even if they're serverless. Yes.
Cool.
Yeah. Okay, thanks.
Yep, perfect. Well, once again, thanks for coming up and spending the time with me. I'm around all day today and tomorrow. And if you would like more of this, then please pop in tomorrow afternoon, and I would love to talk about microservices. Thanks very much.